Hello, my name is Dr. Brady Carter, and I am a senior application scientist for Neutec Group, who provides uh, laboratory solutions in a wide variety of different options. And today, for this webinar, I'd like to talk about and describe some case studies where these solutions that Neutec provides have had a major impact or effect, and how they can be effective uh, and provide an impact on the things that our customers do on a day-to-day basis. And these will be real life situations uh, that show uh, the um, the value that can come from having effective and good laboratory solutions. So Neutec Group provides a wide range of laboratory solutions grouped in basically two main categories. One is microbiology lab automation, and the other is QA analysis. And you can see that there is a wide variety of different options available in the microlab automation. There's everything from an XY tube filler to auger preparation to plate pourers. And then on the other side, there's smart diluters, mixing, auto mixing, um, inoculation automation, and colony counting that all help to speed up and move along the process of doing microbiological testing. On the QA analysis side, we have several different options. One is water activity, which is, of course, a critical measurement for determining the safety of products. Also offer multispectral imaging, which can be used to detect adulteration and sort based on color, shape, count, etc. We also work with flow cytometry, which can look at toxicity on cells or viability of cells. And then we provide a slide staining option. Now, in the case studies that I want to talk about, based upon those solutions that I just introduced that are available from Neutec Group, I want to talk about first, it will be focused on water activity and water activity applications. And there's three main areas that where water activity has an impact on shelf life. One of those is by its effect on microbial growth. The other is its effect on chemical reactions, and the other is its impact on physical characteristics or texture. All three which are very critical for products, depending on what type of product you're working with. Then I want to spend a little bit of time talking about adulteration, in this case, economically motivated adulteration that we can see happen when people are buying spices as a potential ingredient. And then I'll finish off with an example from a food manufacturing plant that needs to do microbial challenge testing off of to verify their sanitation programs, but are faced with challenges because of in our current atmosphere, there can be a limited availability of workforce. So this first case study I want to discuss, so we have a manufacturer of a nutraceutical powder. So this could be an example would be like a protein powder or a exercise enhancement powder. You put it into a container and you add milk or you add water and you mix it up, and of course it's a beverage, and then you drink that beverage, get the nutritional value of it, and it's a great way to be able to get that extra nutrition in a fairly pleasing way for a consumer. So overall, fairly a very nice product. The problem was they were making this nutraceutical powder. It's an instantized powder, so it means that it's got to be stable and stay as a free flowing powder until it's time for moisture to be added, and then it goes into solution and makes a beverage. But what they were seeing was they would manufacture this powder and put it in the container, and then somewhere along the way, before it got to the consumer, it was encountering moisture in different forms or from different sources. And as a consequence, they were seeing some of their products showing up caked and clumped. And the problem with that is that when you take a caked and clumped instant powder and you try to instantize it and put it into liquid to make a beverage, it's really difficult to be able to get those clumps to go to solubilize. And so what you end up with is a very clumpy beverage, not real desirable to drink for a consumer. And so at that point, the consumer is likely to reject that product, and as a consequence, there's a complaint made, and then there's the potential for a reputation to be built for this particular product that it's not good. And as a consequence, this company faced the possibility of losing millions of dollars of lost product. So they came to Neutec to see if we could help, uh, since we work with water activity and work with moisture, in figuring out how this moisture, this contact with moisture before it being delivered was causing them such big problems. And was there a way, a strategy that could be used to effectively address this issue? And so we started investigating, and we ran, one of the first things we did was obtain a dynamic isotherm for this powder, and that's what you see shown on the screen. An isotherm is the relationship between water activity and moisture content. And what this will show is a lot of interesting things, mainly how does, when something is exposed to higher moisture, higher relative humidity, what will happen to that product. These dynamic curves are a special type of isotherm, though. They have very high data resolution. And as a consequence, they show these sharp changes or inflections in the isotherm curve. And when this occurs, and we can view it and see it here, what that indicates is that this material, this powder, is an amorphous powder in a glassy state. So when it's processed through spray drying and other approaches, what happens is that that spray drying process puts it in this amorphous glassy state as opposed to a crystalline state, which is a more stable condition. And the reason why there's an advantage to that is because these amorphous powders are more easily instantized. So that's one of why you would process it that way. But also, as long as you can keep it down in that glassy state, it will be metastable. It will stay. It will have a very extensive shelf life. We're talking years down here. And what this inflection point indicates is what's called a glass transition. It's a transition from the glassy state into what's called a rubbery state. But more importantly, what that means in terms of the product is in this region, when you go past this critical point and experience that change, also leads to caking and clumping, and everything speeds up once you've moved past that point. So from this information, what we were able to see is that as long as the water activity of this powder was down in the lower range, then they were fine. But if water came into contact with that powder, then it would start to take up moisture, and we could track that right along this isotherm curve. And what we find is that due to that exposure, eventually that the samples of water activity will move to values higher that inflection point. And then you take and look at that, and now you've got caked product because of that transition makes it much more susceptible to caking and clumping. So we can identify that inflection point as the critical water activity. So as long as you can maintain conditions of this powder to water activities less than that critical water activity, this powder will remain free flowing. So as long as you can maintain it down there, then it should have an extensive shelf life. Once it moves past the critical water activity, it becomes susceptible to caking and clumping. And the time that will take starts to be faster and faster the further you move along the isotherm curve away beyond that critical water activity. And this critical water activity is also related to temperature. In fact, glass transition is often identified by a TG, which is a glass transition temperature. In this case, we're identifying a critical water activity for this transition. But in either case, the temperature and the water activity impact each other, meaning that if you were to increase the temperature that you ran this isotherm, what you would see is this inflection point would move to lower values. So increasing temperature moves the inflection or the point where it will transition to a smaller value. So that's critical too, because while this data point at about 0.4 water activity is okay at 25 C, there's a good chance that at say 35 C, the critical water activity is on the other side of it, which means it's now on the wrong side and will start to cake and clump. So having a good understanding of this, and we were able to look at it at multiple different temperatures to be able to identify for this company exactly where that critical water activity is and how it could be impacted by potential abuse conditions. And so what was the solution? How could they, so they could manufacture this product to a free-flowing powder and then put it in their packaging and then send it off. That was working fine. It was, the problem was that then it was showing up to the consumer caked in clumps. So somehow it was coming into contact with higher relative humidity that was greater than this critical water activity at some point along the way, and that water was effectively getting in and causing the water activity of that powder to increase. So how can we prevent that, or what was the solution? Well, if it encounters moisture again, one of the most effective ways to be able to prevent that from the change from happening is through the use of packaging. And each packaging material that you could potentially use provides a different level of moisture protection. It has a certain moisture permeability associated with the packaging. And in most cases, the better the packaging is at keeping moisture out, the more expensive the packaging is. So there's some things to think about here. So they may be able to use packaging to effectively stop this from happening, but at what cost? But ultimately, it's the packaging that the product's in that has the potential, when it comes into contact with high moisture, to stop it before it moves past the critical water activity, or at least delay that for long enough that the product will have a practical shelf life, or the expected shelf life, and still arrive to the consumer free flowing and able to be instantized. So we started working with them, and were able to help them figure out exactly what packaging they would be best for them, because there's plenty of packaging options out there. And of course, packaging has other purposes. It provides, often in a lot of cases, it's an advertisement in of itself. It's supposed to be appealing to consumers. It provides physical protection in addition to oxygen protection, as well as, of course, moisture protection. And so we were able to work with them and look at a couple of options for packaging. So one option would be, say, just a plastic container. This is lower cost, but it has a higher permeance. And we can even look at what that permeance is, or what's often called a water vapor transmission rate, or a WVTR. That's often what's reported for this packaging to identify their moisture barrier properties. If we know what that value is, we can use Fick's first law of diffusion to identify and even model what the change in water activity will be inside of this container over time, depending on what the outside relative humidity is. And so we can do that for any type of packaging. So this foil lined is going to be more expensive because the water vapor transmission rate is much lower. So it's much better for that. But it comes at a cost. And it may cause this company would have to adjust their production. But they do so with knowing that because of that better water vapor transmission rate, that they for sure would have a protected product. But there's got to be a balance in this. You don't want to spend too much so that you're losing money or not getting the profit that you need. But at the same time, you want to make sure that your product is protected. And the best way to do that is through actual modeling, to do predictions. And so we were able to do that and help this customer with the modeling and figure out exactly what type of packaging they needed. So once that was done, then the process is, we've identified the critical water activity through the experimentation that we're able to do, and through the isotherm, the dynamic isotherm. So we know where that is. So we help the customer set their specification to a value less than that, to make sure that they would manufacture their powder to a water activity that's safe. And then make sure that they check that by measuring water activity. So that critical water activity can be checked to make sure they're below it using just water activity instrumentation. So that's something that they would need to do routinely, is check the water activity. That's a fairly simple, straightforward test. You put the sample in and you run it. And these instruments are available from Neutec Group, made by Novacina, a Swiss company. Very high reliability, very good accuracy, and easy to use. And then we use the packaging model to help them determine the best packaging that would prevent the water activity from changing as it went and was delivered, because that's the full story. You manufacture to the good correct water activity, you verify that with the water activity instrument, and then you put it in a package that's going to be an effective barrier no matter what type of abuse conditions they might encounter. Our second case study had to do with a manufacturer of a low moisture snack. This is manufactured to have a certain crisp texture to it. So it's manufactured typically to a fairly low water activity. And so they were making this product, and they baked it. Everything was okay after baking. Put it in a truck to have it shipped, sent out, and then all of a sudden they were getting a lot of complaints back from the consumer that were buying these products, that the product smelled rancid. It had a rancid smell and odor to it, and even flavor to it. And so, of course, these products were being rejected. Again, uh, whenever these products are rejected, that of course means millions of dollars lost by the company, both because they can't sell the product, but also because they have to recall it to get it back, and they also have the reputation problems that can go along with having a product that shows up failed to a consumer. So they were, of course, very anxious to be able to rectify this. And the first step they took was just to change their moisture. They were releasing this product based on a moisture content of about 4%. And the first thing they decided to do was to increase that, and just to see what would happen if they were to increase it. So they increased the spec to 7.5, not really knowing if that would do anything. And what happened was that while the product came back failed in most cases when they were manufacturing to 4%, when they went to 7.5%, it was suddenly okay. They weren't having any problems with that product, and so it seemed like they had figured out a solution, but the problem was they didn't know why. It didn't make any sense that if they were to increase their moisture, because in general everybody considers that higher moisture is shorter shelf life. So why in the world would this be? And so they came to Neutec Group to see if we would be able to help them figure out exactly why um, increasing the moisture spec was helping, and further help them identify the ideal specification that they should use. So we came in and were able to right away provide them with a reason, the why, that increasing the moisture spec was helpful. Because they weren't tracking water activity and only moisture content, what they didn't realize is that their product was being made to about 0.15 water activity. So down in this range. And what you see is that for lipid oxidation is a fairly unique chemical reaction in that it starts to increase its rate of reaction at very low water activities. So you have a minimum point, and notice that it's higher than that 0.15 they were manufacturing to, more in the 0.3 range, which is closer to what they increased to. And so that's why they were seeing that increase in stability, is because the rate of the reaction at the higher moisture spec was lower. And we know that based upon this relationship between water activity and reaction rates. We wouldn't have ever known that for moisture content, because we can't tell that range because it's different for every kind of product, because water activity is what's driving this. So as soon as it was clear that the early water activity was at 0.15, it was immediately clear why that was less stable than moving to a higher moisture spec. And the reason for this is because lipid oxidation, for this reaction to occur, requires the formation of free radicals. And these free radical formation, the formation of these free radicals is catalyzed by the presence of metal ions. As water activity increases from desiccation, you start to see the formation of these monolayers of water, these hydration spheres that form around metal ions, and it makes them less effective at catalyzing the formation of free radicals. When you go to desiccation down in this low range, then those disappear. And so those metal ions are much better able to to create these free radicals needed for lipid oxidation. And then you get the added benefit of higher diffusion of oxygen at very low water activity, and that's why that increase happens as you go to low water activities. Then it goes through a minimum, and then you start to see it go up again because now mobility of oxygen and metal ions is starting to increase again, and so you're getting a faster rate of reaction. But that's why the minimum for this is not at the driest point or the lowest water activity. So we decided to do some investigations here to see what was, if we could identify where this ideal range was. So we knew that going higher was better, but was the value, was the where they had moved to, was that ideal, or could they do, is there a better water activity to consider? And so it controlled water activity to different levels down in the low range. And of course, that was unacceptable for rancidity. Into the mid range between 0.35, where they had adjusted, or 0.4, where they had adjusted, and up to 0.6. And then at 0.6 or greater, they had ran these isotherms and had found that through this isotherm work that the texture started to fall off when you got above 0.6. And if you get up at that high, it starts to become unacceptable from a microbial standpoint. So it was clear based upon these results that we could identify a safe and optimal region for in terms of water activity where this product would maintain its stability, and regions below, both above and below that were unacceptable. So the recommendation for this company was to make sure that they manufactured into this water activity range. And that's water activity driven, not moisture content driven. So the other recommendation was to stop trying to release off of moisture and release off of water activity, because that's what's driving these loss in this loss in stability, either due to texture or due to rancidity. And so here's their original specification down there in the low range, so it's clear why that product was failing. They adjusted and have moved up into the green region, so that's why it was stable. But again, it was because they had increased water activity and also then, of course, the moisture content, according to the isotherm curve you can see here. We recommended a specification even higher that sits sort of in the midpoint of this range of acceptability at about 0.45 water activity. The added advantage is that's at a higher moisture content, which means less processing to get to lower water activities and having more water, your cheapest ingredient in the product, that's sold on a weight basis. So this not only makes the product more stable, it also optimizes production and increases profitability for the company. So all around, it's a great solution. And the reason why it was not a good idea to use moisture content as their release specification, besides the fact that water activity is driving this, the other reason is because there is a fair amount of error associated with moisture content measurements. A high enough level in some cases where you can have a reported moisture that seems okay, when in reality the actual moisture, because of error and error that you can't account for, may actually be much higher. So the moisture spec would say release. As long as you're measuring water activity, though, this won't ever happen, because you would immediately know that that water activity is in the unsafe region. So you could, if you move to measure releasing off of just water activity, then moisture content can be sort of an afterthought. It's a way to optimize production but meet the standard of identity, but it's not driving the stability and setting you up for a situation where you could have failure. Because water activity, which is driving this, never fails. As long as you meet the water activity specification and you use the instrument correctly, then you're going to be okay. So our recommendations were to adjust the specification to 0.45 water activity, which corresponds with an 8% moisture, which is much higher than they started out at 4.5, but it's a stable product. It'll keep it safe for the shelf life of the product. But they need to shift to release based on water activity. And that, of course, has to be monitored with a water activity test using a water activity instrument, again, that Neutec provides. And due to potential errors and problems that could come from trying to release off of moisture, it was our recommendation to release off of, to avoid releasing off moisture content, to set them up, because it could potentially set them up for a failure. Our third case study with water activity has to do with microbial growth. And so we have a company that makes a pet food product. They've made it to a 10% moisture content specification for 10 plus years, never had a problem. The product is very popular. They have a great reputation as a really good pet food company. So they go on, they're making this product, still making it to 10% moisture content. And then all of a sudden, customer complaints start showing up that their product has molded and it's showing up moldy and consumers are rejecting it. They have to do a recall to get this product back because it's all molding and there's the potential for mycotoxin production, which can be very dangerous to animals. And so all of a sudden they've gone from a very good product to a product that's coming back millions of dollars lost, and they have no idea how this could happen. The spec didn't change. How can they suddenly have moldy product? And again, with the last case, this would have never happened had they been measuring water activity, because moisture content does not control microbial growth. So even if you have the same moisture content, if you don't know what's going on with the water activity, then you set yourself up for these kinds of problems or disasters. Because microorganisms don't care how much water is present, they care what the water activity or the energy of water is. And here's a breakdown of where those cutoffs are. So if you were below 0.7, that's the practical limit for mold. So they were, of course, their product had moved above 0.7 in some way. When it was below zero point 0.7 previous, it obviously had moved above 0.7, even though their moisture content as they were measuring hadn't changed. It was clear what was causing this, that it had to be at water activities higher than 0.7. So we knew that right away. And this is just to show why moisture content doesn't have anything to do with microbial growth. So a microorganism is essentially a semi-permeable membrane that surrounds a sac of solute, if you will, that has a certain water activity. And these organisms, for their metabolism, depend on water moving into their cell to maintain their turgor pressure and to undergo their metabolic activity. When they encounter an environment where the water activity is less than their interior, that's called osmotic stress, and water starts to leave because water moves from high energy to low energy, not from high concentration to low concentration. This organism doesn't care how much water is present, it only cares what the energy is, because that's what dictates whether or not it will come into the cell. So when that water activity is low, water moves out, turgor pressure lost, and the organism can't grow, it can't reproduce, it can't go through its functions. So it tries to respond, and each organism has its own unique ability to respond to this stress, and they do it by concentrating solutes in their inside their cell to try and lower the internal water activity. And if they can lower it below the environment, then water starts to move in again. And each organism has its own ability to do this, and that's why they each stop growing at a different water activity. But if they can't lower it to below the environment they're in, then they have to go dormant. And they can start to, some of them can form spores, which can last for a very long time. Notice that not anywhere we talked about the cell dying. Water activity is not a kill process or a kill step. It simply prevents growth by not letting these organisms have access to the water that they need because the energy is too low. So they can stay in these dormant states for a very long time and still remain viable. They just aren't going to be actively growing until they encounter an environment where the water activity is higher and water starts to move in the cell again. So what was the cause? Why did the moisture content specification fail them? And of course, the basic answer is they wouldn't have. They've been measuring water activity. But what happened was they had switched their moisture content measurement method. And in so doing, had been in the process of doing that switchover, they had followed the recommendations of the manufacturer, but were getting the incorrect answer. So while it was matching with what they expected and what they were getting before at, say, 10%, the actual moisture content, because of this error, was actually at 12%. So even though they were showing 10%, the real moisture was 12%. And of course, 12% associates with a water activity well above 0.7. And that's why this product was safe before and now was molding. Even though they didn't detect any difference in moisture because of these issues, again, had they been measuring water activity, it never would have happened. Would have saved them millions of dollars. And so the solution, of course, was to track water activity instead of moisture and release off of water activity and not release any product whose water activity was greater than 0.68. And they could do that with their current moisture specification, but we were able to help them even further and describe ways they could reformulate and maximize their profitability. Because if you can add humectants into this product that allows for there to be more moisture held, but still be a safe water activity, that's profit. That's money in the pocket from a very inexpensive ingredient, water. And so we worked with them, and this isotherm shows now that shift up because of the addition of these humectants to make a product now that's they can sell at 14% but still be safe. And as long as they measure water activity as their release specification, they'll be okay. If they try to go back to moisture content, then they set themselves up for more disaster. So our recommendations were to adjust to release off of a product only product that's water activity was less than 0.68. Report the moisture content as only as a standard of identity and not as a release. And of course, they have to verify their water activity through water activity instrumentation. And then we were able to help them maximize their moisture content at that water activity specification. And as long as they monitor it with water activity testing, then they can maximize their profitability without the fear of problems. Case number 4 I want to talk about is adulteration of a spice product. So this is a cumin spice, and it could be any other spice though. Spices are often the targets of adulteration. And what's happening in this case is that you've got these two samples. One on the left is a pure sample. The one on the right has 50% of it contaminated with almond husks or almond shells, which is just a byproduct. It's a filler product. It's just meant to fill space and fill weight in this spice shipment. But the price is based on the spice being pure. And so they can get a full price for it, but only half of it's actually spice. The other half's a cheap and filler. And so the company is doing this so that they can make extra money without actually giving all of their pure product that brings the big price. And so this is called economically motivated adulteration. And the real challenge here, though, is not just the fact that people are getting ripped off. It's that they're using a nut product as the filler, and so somebody who has a nut allergy could consume whatever this spice is put into, and with the idea that there's no nuts involved, and now suddenly they've got an allergic reaction that could be quite dangerous. So the idea here is that if you've got a big batch of cumin spice and you make 10 little batches of it and you only put 50% in there, and then you fill up the rest of the 50% with almond shells or whatever, something else that's very cheap, you can still charge the full price, but you now can get 10 lots at full price instead of just one by having this filler. And so that's obviously makes money for whoever's providing this, but it creates a safety issue and as well as a fraud issue. But looking at these two products visually, can you find the almond shells? And it's impossible to see this from a visual standpoint. Yet FSMA new guidelines now put the burden on the people accepting these ingredients and are going to use them as making sure their product has not experienced adulteration. So they have to put preventative controls in to make sure that their ingredients aren't coming in with adulterants, and they have to have a monitoring tool. How can they detect this? And there's a myriad of different potential tests they could use, but each with their own challenges. Things like mass spec or HPLC to identify what's actually there and present. But those tests are quite expensive. They take a lot of training, and they're very labor-intensive, time-intensive tests. They're not things that can be done very quickly on these income ingredients to screen them. So one option to consider is using the use of multispectral imaging. And multispectral imaging takes an image of a sample at a range of wavelengths, all the way from UV up to the near infrared. And it takes them at these individual bands. And so this image is a collection of a bunch of images done at different wavelengths. And the software has the ability to then look for differences or comparisons using statistical analysis across all these different wavelengths to find the best combination that does the best job of distinguishing between different materials that are present. So in this example, you see our two samples of cumin, the pure, and then the one below with almond shells. And again, you can't see those almond shells with just the naked eye. When we transform it through multispectral imaging and statistical analysis, what you see is when it's pure, it just sees one type. When the almond shells are there, it sees both. So it can detect the presence that there is something in there that's not supposed to be there. That may be almond shells. If you know that's what the contaminant is, you can teach the system to recognize both the spice as well as the filler. But it also might be you don't know what the filler is, so you can teach the system to recognize the pure spice, and then it will be able to say something's here that's not supposed to be. And you can even I set up the system to be able to do a percentage on that. But this test is very, very fast, so it's a huge advantage over some of the others that we mentioned, that it can be, once it's been trained and set up, and that's something that we help the customer with initially. So for this consumer, this company that's going to have these spices coming in, our recommendation was to use this multispectral tool as their monitoring tool for their preventative controls to detect the presence of adulterants in any of their ingredients coming in, most especially these spices that are the that can often be the target for economically motivated adulteration. And this test, once it's set up, once everything's trained as a routine test, is just about only about a 5 to 6 second analysis. It takes that about that long to take an image, and it can even be set up with automation, with an autoloader, and be able to take these tests automatically on a large number of samples. And then an analysis is done automatically on it based on how it was taught and what was set up, so that it can then detect any samples that have something in them that's not the spice. So a very effective option to meet the FSMA requirements with a test that's very fast, and doesn't have the huge costs and the labor that's associated with those other types of tests. Our last case study deals with automation in a microbial lab. We have here an example of a food manufacturer or any manufacturer who's making product, and then they have to do a sanitation process to make sure that their environment is kept clean for manufacturing. And one way to do that is to take swabs after sanitation to see if there's the presence of anything. And often this is checked through maybe an ATP test, but in this case, they have a specific organism that they have to identify if it's present. And so that requires a challenge test. That's a little bit more involved. So it has to be sent to a microbial lab, and they may have a central laboratory that does their micro testing. And so they send that off. They take it and do their micro test to look for the presence of these colonies. And normally they get results back in about 2 days. And so they're just down for a little bit while they wait for those results. And then once they get them, they can go forward. The problem is when you have interruptions and unexpected interruptions, where suddenly now some of the staff that's responsible for running those microbial tests aren't available. They can't come in. And so the testing gets impacted. And now the manufacturing plants can't get their results until about 5 to 6 days. And that's downtime, and that's millions of dollars lost in product not being made. The cause of this is that when you have a typical laboratory staff and everybody's there working, you have a certain amount of output that you can do that results in a certain time that's required for throughput. When you have these unforeseen interruptions that impact your workforce, you now have maybe a limited workforce, much smaller than you had, and so their output, of course, is going to be impacted by that. And so they're not going to be able to put through as many tests, and that then results in a delay in getting results back. So what's the solution to this? Because these interruptions could happen at any time. Well, one solution is to automate this process so that steps that have to now be done by workforce may be able to be automated so that just one person who's watching over the instrumentations is needed rather than many, many different staff members. And then when this automation, even during times when there isn't an interruption and the workforce is available, these are skilled workers who could be doing much more important tasks than these routine and repeated tests or repeated tasks that are required to get this process through that could be automated. And that's everything from dilution to mixing to media prep to pouring media, inoculation, and then colony counting. And all of this can be automated through these solutions so that one person starts the process and then watches as it goes through and does all of these different steps and they're able to be by themselves but have very high throughput. So that you have an outcome where you may have a limited workforce, but because of these automation options, uh, everything from, again, a smart diluter to auto mixers. Then on the media kitchen side, you have the auger prep. You hook it directly up to a automated plate pourer. It's pouring the media. They come together at the inoculation step through a spiral inoculation through an eddy jet, incubated, and then it has to be counted, and that can be automated through the sphere flash. And the end result is that with a limited workforce, you can maintain the output needed to get these results in a timely manner. And such so that, number one, interruptions don't have as big of impact on your output, but number two, you free up your workforce to do more impactful things that could make a huge difference. And that's a great example of this is with the current COVID pandemic, where our solution has been able to facilitate the process of getting testing kits available, as well as getting additional results out and determined at a much faster pace. Example here is that you have a certain workforce, and you for these test kits and the testing that needs to be done, you often have to fill a very large number of test tubes. And so this workforce could spend all day with a pipetter and fill up these tubes, and they'll be able to get a certain amount done. Um, but with an automation, this is called an XY tube filler or bottle filler. This system can be set up with any kind of approach to do lots of different sizes of tubes or bottles. You simply tell the instrument how much to put in and program it for where it's at. And then you tell it to go run the program, and it goes in and fills all of these bottles automatically without anybody actually doing any of the labor. So it eliminates the need for somebody to be sitting and pipetting, which can get very boring, to the point where there's the potential for mistakes, but also that person's tied up with that task all day. Whereas with this automation option, now that person can be doing other important work like analysis and other lab work, so that at the end of the day, if you have one person doing the pipetting all day, you get a certain number of test tubes done. With the automation option, you may get about the same number done, but you also were able to do maybe 3 original tests that need to be done. You're able to analyze all the data, all with that same amount of workforce. So that's the real value of automation, is that it makes it possible for you to have the kind of impact that you really should have without spending and having your skilled workforce spending all their time doing repeated tasks that could be easily done through automation. And so our recommendations for these laboratories where they were seeing and having these challenges of reduced output due to interruptions was to work with Neutec's engineers to determine what the best automation setup would be for their laboratory. Again, that may be just automating the media kitchen, or it may be just automating inoculation, or maybe just automating colony counting, where you can now increase your output in colony counting by 20 more a 20 more a minute by being able to have this automation option and have the system that can actually just go down and quickly count the colonies, and you're not relying on somebody having to look at those all day plates all day long trying to count those colonies. And so then once the best approach is determined, then implement this automation to increase the efficiency. And then the benefit of that, of course, for them will be that this automation, implementing this, sets them up for the future, that they aren't going to have this reduction in output when these additional unforeseen interruptions occur. And in the meantime, it frees up their experts and their skilled workforce to better utilize their time doing things that are more important and more impactful with the results, rather than doing the mundane tasks that could be automated. And with that, that's our webinar. I hope these case studies were informative for you and that they were useful. If you want to know more about these case studies, or how we might be able to impact your company, your team through these solutions and if you would like to talk to us about how to best implement them, and solve hopefully some of the challenges you face, um, we would ask you to send any requests to sales@neutecgroup.com. You can always visit our website to get additional solution or resources that show our solutions, videos, brochures, white papers. That's at www.neutecgroup.com. Or of course, you can always call us with your questions or requests. I appreciate your time today, and I hope you have a great rest of the day. Thank you and goodbye.